All right, so today we're going to do understanding proportional relationships. So suppose you and some friends plan to go to the movies and tickets cost $8 each. Well, you'll pay $8 for one, 16 for two, 24 for three, 32 for four, and so on. So the ratios of the total cost of tickets to the number of tickets are equivalent. It means equal. A group of ratios or equivalent are in a proportional relationship. When ratios are equivalent, they all have the same unit rate. In a proportional relationship, the unit rate is called the constant proportionality. So this is what a table would look like. So one ticket is 8, 2, 16, 3, 24, 4, 32. So the ratio, this is x and this is y, so my ratio would be 8 over 1, 16 over 2, 24 over 3, and 32 over 4. They all equal the same thing because if you divide them, you all get 8. So that means my constant proportionality is 8. So they actually just did what we just talked about. So the table below shows the movie ticket prices described above. You can use the values in the table to find the unit rate, which is 8. Notice that all the ratios are equivalent. This is because the relationship between the two quantities is proportional. The unit rate is 8, so the constant proportionality is also 8. You can also use the value of the table to find the rate of change. Rate of change is a ratio that shows the relationship between the two changing quantities, which again will be 8 because it's proportional. We'll get more into that later. So think of two quantities that have proportional relationships and they have certain characteristics. Look at the graph for the ordered pairs. So what it is, I took this table and I graphed on a number line. So we have to start at 0 because 0 tickets cost $0 and it goes up from there. 1 ticket's 8, 2, 16, 3, 24, 4, 32. Notice that the set of points on the graph lies on a line that goes through the origin. Remember, the origin is 0, 0. The relationship between the number of tickets and the total cost is linear. When a set of points lies on a line, the rate of change between any two points is constant. You can find the rate of change on the graph. It is the ratio of the vertical change to the horizontal change. Okay, in a proportional relationship, how are the rate of change, the constant proportionality, and the unit rate related? Well, they're equal. So I said in a proportional relationship, the rate of change, the constant proportionality, and the unit rate are all equivalent. It means they're equal. They're all the same thing. Okay, the two quantities in the table have a proportional relationship. What's the unit rate? Well, I always like to put on my table x and y. So that's x and that's y. I know my ratios have to be y over x. So my first ratio is 6 over 2, which equals 3. My next one is 12 over 4, which equals 3. So my unit rate is 3. So for every $3, I get to download one app. 3. The unit rate represents the cost to download an app. What's the constant proportionality and the rate of change? Well, since it's proportional, that means it's 3. 3 because the quantities are proportional. The unit rate, the constant proportionality, and the rate of change are all equal. Describe the graph of the relationship. So since the table is proportional, the graph would be a straight line that goes to the origin, which we learned on this slide. Okay, now you try one. The table shows the number of calories for different servings of strawberries. The two quantities have a proportional relationship. So again, I like to draw my x and my y. So it'd be 141 over 3, which equals 47. 282 over 6, which is 47, and so on. So since it's a proportional relationship, the rate of change is 47. That's it. That's the main idea we're doing today. Thank you, guys.